Hello my Linians, this is Teacher Hinaro, and today I am going to discuss the topic how patterns were generated and how to illustrate arithmetic sequence. This tutorial is based from your learning activity sheets in Mathematics 10 Quarter 1 Week 1. So please have the learning activity sheets on your hand and make sure to turn the pages as this discussion is moving on. Our learning targets for this session are the learners generate patterns and the learners illustrate an arithmetic sequence. Before the lesson, let us have some warm-up questions. I have provided 2 questions for you to answer mentally. Number 1. If 1 times 1 equals 1, 11 times 11 equals 121. 111 times 111 equals 12,321. And 1,111 times 1,111 equals 1,234,321. Then, what is 111,111 times 111,111? Your time starts now. Time's up. What do you think is the correct answer? Very good. The correct answer is 12,345,654,321. Number 2. If the pattern continues in the figure below, how many dots could be on the 8th figure? Your timer starts now. Time's up. What do you think is the correct answer? Excellent. The correct answer is 36 dots. The 2 examples you answered are just few of the main examples of sequences made by the concept of number patterns. So let us define number pattern. Number pattern: a list of numbers that follow a certain sequence or pattern. Here are the 2 examples of numbers made through number patterns. Example 1. 1, 3, 5, 7, 9, and so on. The numbers are made in simple manner that starts at 1 and adds by 2 every time. Example number 2. 16, 8, 4, 2, 1. The numbers are made in simple manner that starts at 16 and divides by 2 every time. These 2 examples, dear students, represent 2 of the sequences that we are about to tackle in the first quarter of Mathematics 10. The example number 1 is an arithmetic sequence. The example number 2 is a geometric sequence. But we will not tackle both at once. Instead, we will start first on arithmetic sequence. Arithmetic sequence is a sequence in which each term is obtained by adding a constant d to the preceding term. The constant number d is called the common difference. But how to illustrate arithmetic sequence? Example: the numbers 2, 4, 6, 8, 10, and so on illustrate an infinite arithmetic sequence, whereas the first number is 2 and it adds 2 every time. Therefore, the common difference is 2. Let us now start illustrating arithmetic sequence by answering this example. Number 1. Illustrate an arithmetic sequence with first term 1 and whose common difference is 3. To answer the problem, write the first number stated followed by the numbers obtained by continuously adding a 3 as its common difference. Do you already have the answer on your mind? Let us see if your thinking is correct. The answer will start at 1 followed by 1 plus 3 equals 4, 4 plus 3 equals 7, 7 plus 3 equals 10, 10 plus 3 equals 13, and so on and so forth. Thumbs up for those who get the correct thinking. You can do it next time for those who did not. Example 2. Illustrate the sequence of numbers formed by the arithmetic sequence whose equation is a sub n equals 2 times n plus 1. This problem is a little bit different from the example number 1 because the first term and the common difference are not given, meaning we need another approach to solve the problem. Do you have an idea on how to do it? Thinking. Aha! I got it! There are two related approaches that we can use to solve the problem. First is by determining the first term a sub 1 and the common difference b. The first term will be solved if the variable n will be changed by 1. So, a sub n equals 2n plus 1 will become a sub 1 equals 2 times 1 plus 1. 2 times 1 is 2 plus 1 is 3. The first term is 3. Yay! Now, what do you think is the common difference in the equation? Do you have any idea? Alright. The number 2 beside n in this equation will be the common difference. Finally, we got the correct answer. Our answer should start at 3. 3 plus 2 is 5. 5 plus 2 is 7. 7 plus 2 is 9. 9 plus 2 is 11. And so on. Easy. But wait, there is one another solution. Let us use the same example. Illustrate the sequence of numbers formed by the arithmetic sequence whose equation is a sub n equals 2 times n plus 1. Solution. We will use the counting numbers 1, 2, 3, 4, 5, and so on as the values for n. Substituting these numbers in the equation a sub n equals 2 times n plus 1, then a sub 1 equals 2 times 1 plus 1. 2 times 1 is 2 plus 1 equals 3. A sub 2 equals 2 times 2 plus 1. 2 times 2 is 4 plus 1 equals 5. Using n equals 3, a sub 3 equals 2 times 3 plus 1. 2 times 3 equals 6 plus 1 equals 7. Using 4 for n, a sub 4 equals 2 times 4 plus 1. 2 times 4 is 8 plus 1 equals 9. Using 5, a sub 5 equals 2 times 5 plus 1. 2 times 5 is 10 plus 1, 11, and so on. Did you get it? Amazing! It's done! Now, let's have some recap. What is number pattern? Number pattern is a list of numbers that follow a certain sequence or pattern. What is arithmetic sequence? Arithmetic sequence is a sequence in which each term is obtained by adding a constant d to the preceding term. The constant d is called the common difference. How patterns are generated? Number patterns are generated if it follows a certain pattern or sequence in writing them. At this point, turn your activity sheet into enrichment parts. Reminder, do not write anything on your activity sheets. Write your answer on a separate long bond paper. For enrichment activity 1, fill in the next numbers and write the pattern used at the right of each item. Follow the illustrative example shown before your task. For enrichment activity 2, illustrate the numbers in arithmetic sequence. Follow the instructions for numbers 1 to 3 and for numbers 4 to 5. And for the wrap-up activity, find the first 5 terms of the infinite arithmetic sequence defined by a sub n equals 3 minus 5 times n. 2. Cite a real-life situation that illustrates arithmetic sequence. Good luck! I hope you learned something today. If you have questions or clarifications regarding the topic we discussed, feel free to contact your subject teacher through text or call. Or you may also post your questions in our Facebook group or page. That's all for this session. Thank you for watching and don't forget to like and subscribe. Bye-bye.